Okay, hello. Um, my name is Javin Ahuja. I'm a current, junior at the University of Maryland, College Park, studying computer science and with a concentration in ML and AI. Um, and I applied for this full stack role, and I know this is a little bit late, um, but I hope someone can take a look at this project because I generally think it was a pretty cool idea. And I think it deserves to be looked at and maybe given a shot at for the role. Anyways, enough of that. But so my idea, my idea was called the Timeline Thinker. Before I even get into like what it specifically does, I'll give you a problem. So imagine that you're a student, or you don't even have to be a student. You can be a normal, everyday person that just likes to learn. Because, it's in our human behavior nature to learn things and to understand things, right? Um, and suppose, whether it be related to work or to school, you have an important deadline or something that you have to, learn or you have to, do coming up or study for coming up, and the topic that you learn. So for an example, like if you're a student, right, for some simplest example, if you're a student in school, and you learn something in math, and now you've completely forgotten that topic because you learned it 3 weeks ago, and you have a midterm coming up within a week. um, you would have to probably go back through your notes, or videos or lecture videos, or online resources that you might have watched on the previous days, like the last few weeks, and just basically go through the emotions again and just try to catch up to where you were now. And this will ultimately waste a lot of time because because in this day and age, we all take information differently. We take it through notes, we take it through online lectures, videos, media, and so but this may becomes a problem because um, ultimately there's not like a set way of it becomes hard to go back and figure out what you learned on specific days and what you did at specific what conversations or what things you might have been learning at that specific time, and you really want to go back and see what conversation you might have had or what thoughts or ideas you had brewing at the time, which can be useful in hindsight to learn off of and quickly you know go over. So timeline. Um, and so I get okay. So before I even so basically the point I was trying to make is that since we have all these different medias of knowledge, um, that we're taking in, it becomes we're basically drowning in knowledge, but we can't access it when we need it. Is the point I was trying to make. Meaning that we have all this resources and information given to us, but it's kind of hard to go back and reconstruct or try to relearn the information um, when you initially learned about it, and that's a big problem, and it wastes a lot of time because you're going to doing go back and do the same things that you did like a while ago. So basically, the vision behind the Timeline Thinker is that it solves this by acting as your AI powered second brain with a key innovation. It's temporarily aware. So meaning that it just doesn't store your information and answers questions about it or provides insights about it. It allows you to build a living timeline of your knowledge, and you can ask it questions like, suppose like if I was learning about in my CS class and my ML class, I was learning about transformers, right? And I can ask it something like, what did I learn about transformers last month? So then the system or the application would have enough awareness to go back and sift through all the data and see, okay, what did he go, first of all go through the transformers, see wherever I might have learned about talked about transformers in the data, and then ultimately try to find the date and the time, or the period of time of the last month, and trying to figure out, okay, this is where, this is what he learned, and this is the conversation he had on what he was learning about transformers, and then it can just give you back that information instead of you having to go back and manually do it yourself. And so I think that would be like, that's a very cool idea, and just saves a lot of time of you having manually to go back to things you've learned, when you can have a system that already has this inbuilt knowledge, timeline knowledge of your data, and you can let you know what you learned on what day, and what you talked about each day. And this could be very useful for summaries, and just in general, like quickly catching up, and just having an idea of what you talked about on previous days, and it should save a lot of time. And so basically, the timeline thinker pulls relevant chunks across your knowledge base, and then ranks them by both semantic similarity and temporal relevance, and synthesizes a comprehensive answer using the sources citations, like using the sources as citation. So this would allow you to, first of all, know what source you used first, and then second of all, this will give you the time. So if you were looking for trying to like go back to a certain time or a specific date, it can give you that information and knowledge. And you can therefore you can learn about it, whatever you learned about that day. And you would have just saved yourself a few hours worth of work. And so, okay, enough yapping about the idea. This README, guys, is kind of out of date. I'm gonna have to update it, so I'll probably update it sooner after the video. So I'm gonna do a little bit of my explaining, but the information is more or less kind of similar to what's kind of mentioned on the PDF. Some things are a little different because I made some changes after this README was updated. So if you do hear me saying some things that might not be completely on par with the PDF, don't worry about it. It's going to be updated when I submit it. Okay. So now we're going to go quickly into the architecture. The system has 3 layers: front end, React application with Vite, and this handles the timeline visualization, the session management and chat interface, and then the most important part is the backend, which is made with a fast API using Python, and this is where the intelligence lives. It is a multi-agent retrieval pipeline, and this pipeline orchestrates, uses AI agents, and along with the AI agent pipeline, we have a database, and within my database, I'm using PostgreSQL, and with a PG vector extension. And this is very critical because it gives us native vector similarity search at the database level, meaning that I can perform similarity search within the database, within a PostgreSQL database. Perfect. And so I want to quickly go over my ingestion pipeline, which you're also probably seeing over here in the architecture overview as well. And so in the ingestion pipeline, this is a multimodal system, right? So I can upload audio files like MP3s, MA4s, I think that was it. There might be something else. PDFs, markdowns, and web pages, which you can parse through. And basically, the ingestion pipeline, in very high technical overview, can take these different forms of media or information, chunk them, make these events or embeddings, and then ultimately make them into timelines and sessions. That's a very high overview. I'm going to go a little bit more technical on how this works. So step 1, which within the ingestion pipeline or the content extraction, I use different libraries based on the different file types, obviously. For PDFs, I use something as simple as a PyPDF2 and PDF Plumber for robust for text extraction. And then for audio, I obviously used OpenAI's Whisper API for transcription. It's not the most accurate. I actually knew about it's actually kind of funny. I actually knew about the TwinMinds Year 3 model. I just didn't want to use it because, I was using OpenAI a decent amount, so it made sense for implementation and efficiency purposes. I used OpenAI's Whisper API, but I know TwinMind Year 3 is a really good model because my friend who worked on it, Harsh, he was able to show me the power of this model, and it's insane. Ultimately, if I were to redo this again, this is a good thing to know. Or some changes I would make is one of the first changes I would make is just use twin mind model year 3. Probably the best model out there for text to speech. Anyways, back to the ingestion pipeline, and then also for web pages, we scraped using Beautiful Soup with custom parsers to extract the main content and filtering out like any navigation and ads. And so then that brings us back to the next part, which is chunking. So for chunking, I split the content into semantic chunks using a 500 token window with a 50 token overlap. And this overlap is crucial as it ensures that we don't break the context of the window at chunk boundaries. And then that brings us on to the next step, which is the embedding generation. Each chunk, which is made from the chunking part from step 2, is then converted into a 15 by 1536 dimensional vector. And this is using OpenAI's text embedding 3 small model. And these embeddings basically help us capture semantic meaning, so that we will have basically we can use these embeddings to have similar vectors. Basically these embeddings will help us capture semantic meaning. And then so we use that for semantic meaning. What else? Okay, step 4, storage. Also, this part goes parts with embedding as well. I created an event record, which is where it says events, and if you see here it says events and embeddings. I say event record for each chunk with its timestamp, and then store the embedding in a separate event embedding table. And then this is ultimately joined within HNSW index with PG vector for fast approximate nearest neighbor search. Some technical jargon I threw up there, but definitely good to know. And then last is I think it was entity extraction. I use GPT-4 to extract entities, people, organizations, concepts, and topics from each chunk. And then these ultimately get stored in separate entity and topic tables, which I made with many to many relationships, and this is what enables cross-referencing across like different sources. Okay, so that was a lot of technical jargon, and then I'm gonna go quickly into the multi-agent retrieval, and then I think I will transition to a demo, like a live demo. Okay. So I ultimately used 5 different agents, specialized agents within this application. The first agent being, does that mention it here? Nope. I'm gonna go back up. Okay. So the first agent being here, I have mentioned here, being the planner agent. What it does is basically the planner agent uses GPT-4 to analyze the question that we ask, and then it classifies the query type. Is this temporal? Is this conceptual? Is it specific to a source? And then it extracts entities, and then it determines like a search strategy for the specific question. So if I were to ask a question like, related to something with time, like, when did I learn about this topic, right? So then obviously I'm not specifically asking about the topic specifically, I'm asking about when I learned about it. So I guess an example would that be like the the agent will then realize like, oh, this guy's the user's trying to ask about temporal strategy, retrieval strategy. So he'll probably, so this agent will go back through the data and and then so the planner will just classify the query type as temporal. Obviously, is what I'm assuming. And so basically, the planner helps like basically plan out the query type, and basically classifies the question, and and then also extracts identities, and basically determines a nice search strategy. And then the next thing is a time retrieval agent. You can also see it here in the step on the next agent as well. And basically what this does is this agent executes a SQL query filtering out events by time range, and then performs vector similarity search using PG vectors cosine distance operator. And so basically, if I were to give it a specific, if I were in my, I guess in my query, I were to give it a very specific date or time or a very specific range, it would perform a SQL search, a SQL command, and then so it filters out the rest of the database, and ultimately performs a PG vector, which is the PG vector cosine extraction, or cosine distance operator. It performs vector similarity search using PG vectors cosine distance operator, which is the extension we give for doing similarity search. And then yes, so that's the main purpose for timeline retrieval. And then we go to document retrieval. This is used for semantic search across all my content, not just specifically for time range. So if we're focused on a specific source, and not specifically just a time range, like if the planner agent identifies it, it's okay, this guy's specifically asking about this source rather than a more of a timeline perspective, then the planner agent will probably direct it to the document retrieval agent, and then the document retrieval agent just does semantic search across the specific source, and focuses and then filters to just that source, where it searches everything, and then does entity linking. And then here's where it gets smart. The agent looks at which entities appear in the timeline chunks, and then basically kind of re-ranks the document chunks that share those entities. So if we bring it back to our example, if timeline chunks mention attention mechanism, like transformers or a specific keyword, then the document chunks mentioning okay, I'm not going to even go over the technical details over that. It's not a lot of time left, and it's just too much work. Ultimately, is what I'm trying to say is semantic search. Document retrieval agent just does semantic search if it's not looking for a specific time, date, or range. And then last, ultimately, we have the alignment agent. And what the main purpose for the alignment agent is, it's supposed to find relationships between the timeline and document chunks, and basically goes through them, and then basically constructs a context window with source citations with timestamps, and then prompts, and then uses that, and then basically it forms this whole window, and with source citations, timestamps, and prompts for GPT-4, and then ultimately it sends that to all this information, basically finds relationships between the timeline and document chunks, makes like source citations, timestamps, and then GPT prompts, and then it sends that to the synthesizer, and then the last agent, which ultimately takes in that information between the timeline chunks, document chunks, which have been given by timeline retrieval or document retrieval, and then basically gives the final answer based on the prompt that is given to the synthesizer, and just it gives the final answer. So it's a very, I wouldn't, it's a very interesting but very useful, I would say, pipeline, because there's like, it goes through different forms of media, and then if ultimately it finds uh, the correlation between timeline and all, then semantic search as seen within timeline retrieval and document retrieval. Then we have the alignment, which ultimately finds a relationship, and then synthesizes, which then ultimately builds the final answer. Okay, and so then obviously for the ranking that I was kind of mentioning a little bit earlier, that I had a little bit of hiccup. Basically, the way that this ranking works is that it's a hybrid ranking. So it just doesn't. So I mentioned this earlier on. It just doesn't use semantic similarity like most traditional rack systems. It uses it mainly. So the way it does is 60% of it goes to semantic search, for semantic similarity from vector search. 20% of it goes to temporal relevance based on how close a chunk is to the time range, and then 20% entity overlap boost. And then overall, this is hybrid, so like it's supposed to be more equal and not just all semantic or all temporal, and it's supposed to find core commonalities between the two and ultimately respond to the user's queries based on those commonalities. Okay, so I think I've been talking for a little bit. I think it's about high time that I show you guys the application. So I want to go to, what is it? Settings, and then we'll just go to pages real quick because I'm hosting this off GitHub Pages. Okay, so this is what the application looks like. Quick demo of the application. So obviously we have our timeline here. 0 days, obviously, because this is the first day, obviously. Would want to make it an improvement. Obvious improvement is we're going to have like a plus sign here, so it doesn't have to be just by day, it can be by different sessions as well. So you can add your more timeline sessions over here, and you can have like a clear set of timeline dates here as well when as the days go on, and you can basically kind of click back on them and see like what you talked about on those days as well. And then you can also have weekly summaries as well, but that's for later. So this is what a current session would look like, right? This is this blank you're seeing here is going to be the overall summary generated from the current session, questions I'm going to be asking during the current session. This is going to be the session sources that I'm going to be using, that I've used within the session. So if I use like a certain source and then asked about a certain source within a session, it will be all populated over here. And then we're going to have focus sources, obviously, in these sources, like you can choose between which source. You can obviously do all sources, or you can choose very specific ones as well. And then you can ask questions about these sources. And then you can upload, so upload different files, different forms of multimodal data information, like you can upload PDFs, Markdown files, MP3 audio files, M4 WAV files, text files, and then you can also, and these are just files you can upload. You can also do like normal like websites and articles, and just copy and paste it, and it'll just parse through the article and get you the information, and you can ask questions about the article, and same thing with the files. Okay, so let's just then we obviously have a clear all button, which clears the session or whatever. So obviously have some, as you can see, I obviously have some things uploaded within the focus source. So I'm just gonna, this is a audio that I uploaded from YouTube, some YouTube short I uploaded. So obviously I click on it here, and then because I want to focus on this specific one, and then I could say, and then my TimelineThinker over here, this chat interface I have down here, it says, ask me anything about information you shared with me, and then I click on it, and it says changes to switch your focus to C will never die MP3 file. So now it's in focus and it's taking that file and knows now whatever question I ask is going to be related to this source. So let's just do something simple like when what is this video talking about? Sure, let's do something like that. And so then the timeline thinker will obviously think. One thing it takes a little bit of time is I would want to optimize the time it takes to respond and upload things on this application, because honestly those things, just having a more optimized function or more optimized program is always better. Okay, so we've got response, and so basically it gives me a very basic one paragraph response about C++ and programming language and whatever was talked in the video about. As new programming languages emerge, C++ has been dying off. And so it also mentions a personal anecdote from 1995, emphasizing the speaker's initial impression that C++ fell old backwards. And despite these expectations, video highlights that the situation in 2025, so trying to bring it to current events where C++ isn't still used. So this is very good for if you're trying to work with dates or timelines and stuff like that. Obviously, you can see it's there's a decent amount of emphasis in that temporal awareness or information I was telling you about. But we haven't asked anything yet where I would think we would need all of this information. Okay. Okay. So we can ask it. I'm trying to think of a question. 1995. We can ask it maybe something about a date, but I think we could low-key just keep moving on. Let's just ask another question. Why not? What do we expect moving? So from 1995, we learned that it's been dying. Right? I was just asking it a question to see what a response. And then we're gonna wait for a response, and then we'll see what it has to say. We're just gonna see, and yeah, it's taking a little bit of time. Yeah, the declining since 1995. However, contrary to expectation, it would die out, especially with the rise of Java. C++ continues to be used as 2025. So, yeah, so it understands the question I'm asking, and it obviously puts a large emphasis on temporal information. Obviously, you can see the use case for this if you're asking a lot of if you're asking your questions about what I learned about this date or this time. This really goes back through the data, parses it, and makes sure it's it puts an emphasis on the temporal information and gets that information for you and spits it out right back out. And also a good thing to know, if it also always gives a source. So the current source that I'm using. So this is good for if we're trying to figure out what source you use to learn something, or whatever source you use to just basically learn something. Okay. So this is based off of an audio file uploaded personally. I can upload another file just to show you that the uploading system obviously works. Let's just upload a philosophy PDF that I learned that I'm doing in my class. Okay, that uploaded, created 24 events. Now I want to ask it, where is it? This one, right? Okay, switch to that PDF. I'm going to ask it, what is this PDF about? Split it down into its main arguments. And then we'll just do that. Don't want to over exaggerate it right now. Okay. it's thinking, obviously. It's going to take a bit. And wow, okay, so we got a good result. It parsed through the PDF, extracted all that text using PDF, and obviously we got a very clear and nice result about the main arguments for the PDF. Okay, so obviously we know that this works, which is good. And so, yes, you can ask questions about, obviously I can't show that right now because, there's not really, we don't have any other days right now, but it will work on previous days. So if I were to ask it a question on some previous source, because it's built off that knowledge base, right? Saying, based on how this application works, it goes back through your query response, tries to find temporal information, and basically parses through that information. And if there's a lot of temporal information in your query response, like say I'm trying to learn about something that I learned about like a few weeks ago, it'll go through the database, make those calls, find that specific piece of information that you talked about or you chatted about in the database or in the application, find the response that it got from the API from the backend, and then it'll push that back out, saying, giving you a response based on what you learned a couple weeks ago. So, for example, if I were to say, I learned how to reteach me the specific concept I asked you to teach me, so like a couple weeks ago, and so then it goes back through that temporal information in the database, filters everything out by using SQL commands, and then so it gets to that specific range, and then once it gets to that specific range, it'll look through the specific topic semantically, obviously, and then once it finds a specific topic, it'll see what you learned and what you responses you were given from the AI, obviously, and then kind of spit that back out. So it's like a nice way of kind of teaching yourself and reinforcing things within yourself if you're studying for things or just trying to relearn new concepts again and again, and basically kind of help reinforce that idea. Obviously, I can't really. I wish I'd done a better job demoing that and showing that, but I think this will make it up. And so now also for each session you have a basic summary that the AI generates at the top. So obviously we used two different sessions, right? We used two different session sources. We used See Will Never Die and then Vandenberg, right to explanation. And so then what it did was basically based on what I talked about it within the chat interface down there, it gave me a solid summary up here about what I chatted with the application about. And so now obviously let's just suppose I'm done for the day, I've had very useful conversations with the AI or the system, and now I want to save these notes somewhere so I don't have to come back to it manually. I can just do save notes, and it will save me a PDF of the notes or session notes for today, and voila, we get some nice generated PDF notes about the conversations that we had today with the different PDFs and what we talked about within the PDFs as well. Right. So, okay, so that was my idea. Obviously, there's a lot of room for improvement. A couple things I did mention for improvement is the database. Database is fine. I used PostgreSQL. PG Vector was fine as well. Ended up pulling all the information out just fine. Setting it up was a little bit of a pain. But no, Fast API was good for scalability in the back end and improving it. And then obviously React in the front end, keeping the website dynamic. As well, I was just thinking in terms of implementation. Obviously, using year 3 model would be ideal for an application like this, for especially when I'm converting from speech to text. That would be the best and ultimately get me the most accurate results. And ultimately, I would have to figure out how to optimize this application in terms of file uploading and file responses as well, and then also work with a lot of the query and caching of this application, as because based on, obviously you can see why there would be a big need for that as well, because some sources might be used a lot more and might be referenced a lot more. So instead of having to pull that up from the back end each time and wasting a lot of time, the chatbot having to waste the agent system having to waste a lot of time, going through through the whole pipeline and again just to get data from the database. It would be much more easier and efficient if we had a cache, Redis cache somewhere, which contain the most used sources or the most used data, and you can just pull it off from there. That's saving me a lot of time and efficiency, just making the application much faster. So yeah, this is my application. Hope you guys like it. I know this is a little late, and I'll be submitting it. And I'm very very interested in what TwinMind does. I've heard a lot of good things about you guys, and I just hopefully all goes well. Might be there one day too. All right, thank you guys. Have a good one.